Hi guys, so let's do stoichiometry calculations. This is a balanced equation and the question says 50 grams of CaCO3 is given. So you are asked to determine the mass of CaCl2. They are not the same, different things. So you are just given 50 grams of Ca, C and O. 3. So you have to determine the mass of CaCl2. Let's look at the equation. You have 2HCl. It's a balanced equation already. Chemical equation. You have CaCO3. This one. You're already given this one. And you are asked to find the mass of this one. What we are trying to find here, it's the coefficient. The stoichiometry coefficient is the answer that comes before an element. That is a stoichiometry coefficient. So we're trying to solve that. And we are going to be using those later on to find the mass of this. Now, the first thing you do is you are given 50 grams of this. So you firstly have to calculate the mole. When you see 50 grams anywhere, know that you have to calculate small m over big M. This is represent this 50 gram that is given. And this one represent the mass on the periodic table. So you are given Ca plus C plus O. This is what you are given. And in your periodic table, the molar mass of Ca is 40, the molar mass of C is 12, and the molar mass of O, this is 3. This number here means this oxygen is 3 times the oxygen. So you have 3 times 16, because the molar mass of oxygen is 50. If 60, the total of this mass is 100. So you can substitute it into the equation. N equals to 50 over 100. N equals to 0.5 mole. Now you have number of moles of CaCO3. A number can say you have 50 grams of this one or this one, and they say calculate the mass, which means you don't have to calculate a mass of another one in order to come to the other one. So it can just stay straight to you just calculate the mass of what you are looking for, right? You don't have two things like this. You don't have two reaction or chemicals or compounds like this. You only have one, and you are given a gram for it. Other questions can say that, and you just have to calculate for that one compound that you are given. But now we have two compounds. So with those two compounds, we can be able to get the mass of this one using this one. That is what is happening here. We are given this to help us find the mass of this. So we are taking the longer route. But it can happen that they give you they take you straight to the mass of the compound that you have to calculate. So it will just be 50 grams of one thing, and there will not be two separate things. 50 grams of zinc, 50% of maybe oxygen, 50% of water, or whatever that they can give you, 50 grams, and you just have to calculate what you have to calculate. You need just to calculate the mole of that thing using a ratio. Now let's complete this. You have 0.5 mole. Now let's say CaCl or 2, and then we have CaCO3. Ratio mole. The ratio of CaCl2 is 1. That is the coefficient, the stoichiometry coefficient that is standing in front. There is 1 here and there is 1 here. Stoichiometry coefficients are ratios. So that is 1, and here as well we have 1. Now we've just calculated the mole of this one is 0.5. And the mole of CaCO3 we do not, no, we've calculated the mole of this one, and this one we do not know, so we'll just say it's X. Now what you have to do is to cross multiply here. So you will say 1, this one times 0.5, and you will also say this one 1 times X, and that will be 1 times 0.5, it's 0.5. So that will be 0.5. 0.5 is equals to X. 1 times X is X, right? So this is your final answer. If maybe we had 3x here, you would just have to multiply both sides by that 3 so that you can get x by itself. So this is what we are looking for. Now that we have that, we can now we have the mole of CaCl2. We are asked to calculate its mass. So the only way we're going to calculate its mass, first we have to find the mole. Now we are going to calculate the mass. So N equals to small m over big N. That mass they're talking about is this one, the small m. You can ask yourself, why do we need this while it's so easy to calculate the mass of this thing just by going to the periodic table and checking its molar masses? That is not the mass we're talking about. The mass that we want here is this one, the grams one. We are given 50 grams of this one. Now we want the gram percentage of this one. So N equals to 0.5 as we had calculated. And then the big M, which is the molar mass, we go to the periodic table. It's CaCl2, which is equals to Ca is 40 on the periodic table, plus 35.5 for the Cl times 2. Ca is 40 on the periodic table, Cl is 2. So that is 40 plus 71, that will give us 110. So we have the mass from the periodic table. And now we can say 0.5, substitute this N, equals to small m over 1. And now when we have it like this, we'll just say the 0.5 is over 1 and we cross multiply. So that will be 0.5 times 111 equals to m, which is the given mass in grams in the question. Given mass in grams. So when you say 0.5 times 111, that gives us 55.5 grams, sorry, 55.5 grams. So remember, you are given 50 grams of this, right, compound. Determine the mass of another one. This is what you get. This is what you put. This is what you got. So you got this. You need to find the mass of this. You are firstly going to find the mass on the periodic table, molar mass of this thing. After finding it, then you will calculate mole of this thing. After finding the mole of that thing, then you can do the ratios. Ratios are numbers in front, stoichiometry coefficients. Then you will do you will write the coefficients of them. Even if it's 2 and 2, it doesn't mean they will always be the same. It can be 3, can be 3 this side. So what you do, you just cross them with the mole that you got. Then this one will be x, and then you solve for x. Simple. After solving for x, you will have the mole of that particular compound or element that you're trying to find the mass for. And then you do find the molar mass of that one using that mole that you've calculated previously so that you got it.